Hi guys, welcome to Learn with W3 Schools. My name is Dr. Dishan and today we're going to continue our R programming tutorial in this channel. We have been talking about R programming and we have used various different concepts already. We have discussed various different concepts already. We have talked about the basic introduction of R programming from syntax, variables, data types, math, string, and the last session covered the booleans. So this is the third session using W3 Schools website as a reference material. We're going to continue and talk more about today in operators, if else, while loops, and for loops. Okay, so we are using W3 Schools website as a reference so you can follow along, use this amazing website. A quick disclaimer, I'm not being paid or this is not an official W3 Schools website. I just love this website and using it so that you guys can also follow along and learn with me as a reference material. So if you still haven't subscribed, please do subscribe to this channel as I'm posting videos on programming and programming languages tutorials using W3 Schools regularly, and hopefully this will be very beneficial if you are into programming and learn more, want to become more expert in programming languages. Okay, so do please subscribe. It helps us a lot. Like the video, let me know in comments what you want to learn and what you have learned already, or what other things you want to explore within the programming, specifically regarding our programming. Without further ado, let's begin. So now we had, as we talked about various different data types previously, let's moving on to operators now. What are operators and how we use them? So operators are used to perform operations on variables and values. In example below, we use the plus operator to add together two variables. So for example, we have 10 plus 5. So this plus is known as an operator. Makes sense, right? And these operators allows us to perform various different operations on variables and values as we go along. So in R, there are basically various different types of operators, from arithmetic operators that involves plus, minus, multiply, divide, self-explanatory. We have assignment operators, we have comparison operators, we have logical operators, and we have miscellaneous operators. Arithmetic operators. Well, arithmetic operators are used for numerical values to perform various different mathematical operations on them, and we have already used with them. So in R, we also have same thing. We can use plus, minus, multiply, divide, exponent, modulus with a double ampersand sign and percentage sign, and then we have integral division as well, depending on how we use them. Now, if you look at the plus operations, well, it's self-explanatory. X plus y will give us the addition, subtraction, x minus y, x multiply y, and divide, and so on and so forth. Same goes with the exponential notation, modulus, which basically gives the remainder divisions, and integral division as well. That has this division sign at the bin between as well. So we have 2% sign will give us modulus, but then if you use the division, it will give us an integral division. Okay, so these are self-explanatory arithmetic operators. I don't think so we have to delve too much into them. Then we have something called assignment operators. Now in R, we have already talked about that in order to assign a value to a variable, we use this arrow sign. Okay, so we can use my variable double arrow sign minus, we can use minus arrow sign to this variable. So this basically means that we are assigning the value of 3 to this variable, or we are assigning this variable values to this 3. Basically all mean the same thing. So this double arrow or a single arrow represents that we assign operators to itself. So if you run the code, you would see that the variable 3 gets printed. So no matter what you do, this my variable has a variable 3 assigned to it. Okay. Similarly, if you go that if you understand that this double variable is a global assigner, you will learn more about this in global variables chapter later on, where we discuss with that. Okay, so it's also possible to turn the direction of the assignment operator. So you can use this direction or this direction as well. Make both are exactly same in R programming. Now let's talk more about the comparison operators. Comparison operators are what we call the logical operators. They allows us to logically evaluate a condition and return true and false to us. So whenever we use double equal to, this basically means that we are trying to evaluate a condition whether the value x is equal to the value of y. So this is what we say a comparison operator does. It compares the value of two variables and returns either true or false for us. Then we have not equal to, which does the inverse. The value of x is not equal to the value of y. Okay, again, either true or false will be returned, Boolean data type. Then we have a greater than symbol, which basically means that the value of x left hand side is greater than the value of right hand side, y value. And then the less than will basically mean the value of x is less than the value of y. And then we have greater than equal to, which means that the value of x is greater and equal to. So the condition means that it can be greater and equal to the value of y. And x is less than or equal to y. Okay, so we have the same thing, greater than or equal to, less than or equal to. So these are what we call a comparison operators are. They give us a comparison or an evaluation of logical values between two operands. from left hand side to right hand side, and the answer, keep in mind, is always in form of boolean. Okay, they always return either true or false. This is where we start to use them in if else and also within the loops as well. Then let's talk more about logical operators in our programming language. What are logical operators? Well, logical operators are operators that combine multiple conditions together. So in previous here, we only check either x or y. So one condition is evaluated: x is equal to y, or x is not equal to y, or x is greater than y. So this is a single condition. Using logical operators, we actually combine multiple conditions together. Okay, so for example, when we want to evaluate whether the value is smaller than something and at the same time bigger than something else as well, so or we're defining a specific range as well. Okay, so whenever you need to use that, we basically use these logical operators that combine the conditional statements. So we use these conditional operators and combine them. We'll talk more about them as we go along. Okay, we'll see more examples. So we have AND operator, which is basically element-wise logical AND operators, returns true if both elements are true and false. So for example, let's just check the example here. So here we are checking 5 is equals to 5, which returns true and false. 5 is equals to 3, which returns false. But at the same time, you can use AND operator, and then you can say, hey, what about 3 is equal to 3? So now what happened is that we have used condition A and condition B. So we want to ensure that both the conditions once are satisfied, only then we get the answer either in form of true or in form of false. So now you get false. Why? Because 5 is not equal to 3. So because this first condition becomes false, the answer becomes false at all. Because the logical AND operator has to ensure that the both conditions are true. So if it will return true if both elements are true. So what this actually means is that now we are trying to evaluate two different conditions. So this is where the logical operators come into play. Normal conditional operators, they only evaluate one expression. Here we are evaluating two different expressions, and then you can concatenate as many expressions as you want. So you can have another expression here evaluating, for example, 5 is less than equals to 6. So this also becomes a perfectly valid reason. So now we have three expressions. So these logical operators allows us to combine and evaluate multiple conditions at the same time. But the condition being that this result has to return true, and this result also has to return true in order for this entire expression to be true. If any one of them becomes false, if this is false, the whole expression is considered as false. If any one of them becomes false, the whole expression becomes false. This is where the OR operator comes into play. Okay, so OR operator, what it does is that it needs any one of these conditions to be true. So if you come back here, instead of AND, if you replace it with OR and replace this with OR, so it says that, hey, any one of them, if they become true, I will return the result true for you. Okay, so see, this result is true. Even though 5 is not equal to 3, this becomes false. But it says, okay, because I have OR operator, I have an option. So if this becomes false, it doesn't really matter. Let me check another condition. So if 3 is equals to 3, because any one of them is true, now it's returning true to us. So it doesn't really matter if this is false or true anymore. But obviously 5 is less than 6, this is also true, hence this expression returns true as well. So the OR operator needs only one of the entire expressions to be true, and has to make sure that all are absolutely true, only then it will return true. So that's the major difference with that. So if you use double AND operator, so it's a logical AND operator, returns true if both elements are true, and then similarly a logical OR operator returns true if one of the statements is true. The same goes with that. So you can use a single pipe or double pipe as well. Then we have a logical NOT, returns false if the statement is true. So this actually inverses the result. So it inverses the result, and instead of if true, it inverses the results and makes it false. So sometimes it is quite useful in certain situations as well. Then in R, we do have certain miscellaneous operators that are also used for manipulating data. For example, the colon creates a series of numbers in a sequence. So for example, you can use X assign arrow function 1 to 10. So this is used inside the loops as well. That means that we want to assign series from 1 to 10 to the variable X. So within a loop, it will loop itself and then assign each number to it and use different number every time the loop rounds. We see the example in the loops section. Similarly, we have percent in percent. Find out if an element belongs to a vector. So it uses in terms of searching. Okay, so we want to use that if X belongs in Y. So if this value actually exists in Y or not. Okay, so we use percent in percent. Similarly, matrix manipulation has percent multiply percent simple. So for example, you can use X belongs to matrix 1, percent symbol matrix 2. Okay, so again, we will try to see a few examples later on in the sections. In matrices specifically, we'll see how we basically use them to get a better understanding how we actually use these in practical life. So do keep this thing in mind as well, that we have these additional miscellaneous operators that we will use later on. Okay, let's move on to if else now. Okay, so coming back to if else. Well, if else are one of the most fundamentally important concepts in programming. They allow us to check conditions of a certain statement. Now, by condition, we means that using if else statements, we state a certain amount of conditions, and if else evaluates whether the condition is true or false. Based on that, it makes a decision whether to execute a certain piece of code or not to execute that code. This gives us the power of controlling the flow of our programming. Okay, so in if else, basically we do use the same conditional operators using equal to, not equal to, greater than, less than equal to, greater than equal to, and less than equal to. These operators allows us to maintain a conditional flow within the systems. They allows us to check the conditions, and based on that, the condition becomes either true and false, and if statement executes certain piece of code. Make sense? Little bit, right? Okay, so these are something we've already talked about. Now, how does if else independently actually work? So the way if else works is that if else is written with the if statement. Again, this if is a keyword, it is a word, bracket start, bracket close, block start, block close. Okay, within the block, we write a certain piece of code, one line, two line, or any number of lines of code you want to write. Now, within the if, we write a condition, okay, using the same conditional operators that we just discussed. These conditional operators evaluate a condition and return either true or false. If actually needs only true and false. It doesn't need this expression. It needs true and false. If the answer here is true inside these brackets, the block of code will execute. If the condition becomes false here, the block of code is completely ignored. That's how if else tends to work. So this block will not execute if the condition here returns false statement to us. So in this example, what we have done is we have A assigned 33, B has been assigned 200 value. So now we're checking the value of B is greater than A. And since the value is greater than A, the condition returns true. And if reading the true condition executes the block of code. In this case, for example, if you change the value to 333, now if you run the code, see nothing gets printed. Why? Because now the condition is false. Because the condition is false, the block is completely ignored. This is what happens when we talk about if-else statements. So if a statement actually reads a condition, execute it. So in this example, we use two variables, A and B, which are used as a part of a statement, if-else, okay, part of if statement, sorry. So to test whether the B is greater than A or not, we use these expressions, assign them the values, and then we use this B is greater than A value. This is what is this whole talking about, okay? So since B is greater than A, it gets printed that B is greater than A. Okay, so R uses these curly brackets to define the scope of the code. So these curly brackets are indicated as a block of code, or sometimes also known as scope in the code, that the scope starts from here and ends here. So the if boundary actually starts from the block of code, starting from this block, ending at this block. So whatever you write inside these two blocks becomes a part of if statement. So if condition is true, everything inside this block will get executed. Okay, then we have something called else statement. Now this is usually goes in hand to hand with if. You cannot write else separately. You have to write if the else statement after the if. Okay, so the if else keyword in R, the way of saying it is that if the previous conditions were not true, then try this new condition. This is how it basically works. So what's happening now is we have if statement. Okay, it evaluates a condition. If the condition becomes true, this block is executed, and everything outside this block, this else, is completely ignored. This will not get executed if the first condition is true. In a situation where this becomes false, now else will execute. So if the if is false, it will execute the else, and then it will have another if inside this else statement. So this will check the condition again and execute the piece of code. Okay, so now let's move on to something called if else. The else keyword itself is used independently as well, along with the if as well. So if you are using the system, you can use else if, or you can simply use if else statement with else is used independent of if. How does that work? Well, for example, if you have a condition if B is greater than A, and then you specify statements that in this case, if the condition is true, you use this, then we use else if. Again, this part is not mandatory, just for an example sake it's written, but here you notice we have only else without any if. Now this basically means that in case both of these statements becomes false, then this becomes the final default execution. If any one of these if becomes true, that particular block is executed and the control gets out. If this becomes true, this first line is ignored. If this becomes true, this line is executed and this else is now ignored, because again we have already a true condition here. These lines will get printed. This if is completely ignored. However, if none of them is true, both this if returns false, then we go to else. If again condition is checked, if this becomes false, then again we go finally execute the default else statement. So you can write else in the as simply as a separate statement as well, but yes, else cannot come absolutely independently. So you cannot just write else has to be written after a given if statement. So it has to be a statement that you write after if. So in this case, again, after this if, we have an else statement. Okay, so you hope you understand that. So now let's talk see another example. So in this case, you see we have two variables. We write if statement and then there's an else statement. So as I mentioned, that this part is not necessary. It doesn't mean that else has to come after every else if statement. It's basically after every if statement. So it does comes after if statement. So technically this else is part of this if, means that if this if becomes false, this else will execute, and there's no condition here, means no matter what, if the control comes to this else, it will execute this statement. So in this case, you can write it simply in this manner as well, where you write if an else statement. If condition is true, execute this block. If the condition becomes false, go here and execute this. So there's no separate condition here to evaluate. This will become like a default statement in case if any of the above statements becomes false. Make sense? So this is what if-else statements allows us to do. Then let's talk more about the nested if-else statement. Well, what do we mean by nested if-else statement? Nested if-else simply means that when we have if inside another if statement. So in this case, you can clearly see we have if statement. So we write if block start and the block ends here, and inside this if we can write any legal statement of our language, which basically means since if itself is a legal statement, inside the if statement we print something statements, and then we have another if statement to further evaluate a certain conditions. So if x is greater than 20, print the statement else. If this becomes false, print the else statement block in this case. And then the block ends here. So this if blocks actually ends here. Then with this if, we have another else statement, meaning that this else is actually part of this nested if else structure, where we have if inside another if, and then it has else, and then the control comes back from this block here, and then this else actually belongs to this f. So for example, if x value is less than 10, and then you execute this, so this code becomes false, right? So for example, if x is only 4, right? So if x is only 4, we say this condition becomes false. So all of this block is completely ignored. None of them will be executed because the condition is false, and the control will automatically be transferred to the else statement. Hence, only this line will get printed. Make sense? This is what nested if else means. So basically, you can nest multiple if else inside each other and do a more comprehensive if else comparison or conditional comparison in your case. Okay, so this is all basically what the logic of if else does. Now, in next session, we will talk more about while loop and for loop. So stay tuned, do subscribe, follow the channel, and we'll try to complete this in next lecture. This is Dr. Zishan signing off.